Botulism. Toxins produced by the Clostridium botulinum bacterium are the cause of botulism. Botulism causes great weakness and can be potentially fatal. There are 3 different types of botulism: intestinal botulism, foodborne botulism, and wound botulism. Though Clostridium botulinum bacterium is found in soil and sediment worldwide, it only becomes hazardous when the bacterium finds its way into the body via cuts or when consumed. Nerve toxins can be produced in food that is not adequately cooked, preserved, or canned, which can then be ingested. Symptoms. Symptoms that can be experienced by adults include vomiting, constipation, blurred vision, dry mouth, difficulty in swallowing, speaking, and breathing, weakness, fatigue, and paralysis of the muscles. Symptoms that can be experienced by infants include constipation, weak cry, loss of appetite, breathing difficulties, less movement, and weakness. Locations where the disease is common. Type A botulism is found most commonly in western US, Argentina, and Brazil. The location common for proteolytic type B is the eastern US. The locations common for non-proteolytic type B are the Netherlands, United Kingdom, and Denmark. It is common for type E to be found in the northern regions, like Scandinavia, Japan, Alaska, and Sweden. The reasons behind botulism having higher rates in these countries is because of multiple reasons. Products with low oxygen content and certain temperature groupings create the growth of the bacteria. Local honeys contain the spores and temperatures create a perfect growth environment. This means home bottled canned food has the potential to grow these sometimes fatal toxins. An example of a low botulism rate is in Australia. Their honey has showed no signs of C. botulinum, unlike the US, and has procedures successful that canned food doesn't grow the bacterium. Places like Alaska with the Inuit people show that their method of canning food is inadequate. They ferment flickers or blubber at surrounding temperatures in jars and spin pouches. This causes the bacteria to germinate and multiply. Seeing these are traditional methods, I don't see them changing in the future, but to prevent botulism, they can cook their canned or bottled food on a high heat for at least 5 years. 5 years is a long time, and traditions do change, but there are chances that they will better preserve or cook their food before consumption. The body's response. Muscles cannot retract because the nerves have been paralyzed by neurotoxin. Neurotoxin enters the nerve cells and interferes with the release of acetylcholine, so the nerve's muscles are not stimulated to contract. The botulism toxin fixes itself to presynaptic membranes of peripheral neuromuscular and autonomic nerve junctions. It also affects the muscular system in the way that muscles are not able to contract. It attacks the gastrointestinal tract, esophagus, stomach, small and large intestines as well. The two systems majorly affected by the neurological disease are the nervous system and the muscular system. The response to this is that the nervous system has then produced a new axon that has had no exposure to the neurotoxin, so that the interference isn't permanent. Axons in the peripheral nervous system are much more able to regenerate than those in the central nervous system. The axon portion, which is disconnected, undergoes Wallerian degeneration. This disintegrates the nerve. The glial cells then remove debris to ensure the regeneration of the axon is successful. The reason the body's response is inadequate is because the body can't defend itself. Botulism isn't very common, so the body hasn't evolved with ways to protect itself from this specific disease. There also isn't a vaccine, so the body isn't protected in this situation, and once in the body, there isn't much the body can do to prevent. For example, the Europeans' immune system had learnt to better deal with the smallpox, but when it was introduced to Australia, it killed many of the local Aboriginals.
How has the understanding of botulism changed from past to present? Botulism cases have decreased over the years as knowledge of the disease has grown. People are more aware of the signs and symptoms, and doctors know how to diagnose these through testing. People are more cautious when buying canned or fresh produce to check if the can is bulging or leaking, because these are signs of botulism, and not to feed infants honey. Botulism was recorded when in the 18th century there was an outbreak of sausage poisoning in Germany. This provoked further study of the disease, but equipment was limited back then and not everything could be identified. The disease's symptoms also misled many scientists in the 1800s to believe this was the work of hydrogen cyanide, but Justinus Kerner foretold the use of the bacteria for medical ailments. He even tried it on himself. But now scientists have categorized the disease and its symptoms. They've found solutions to it. They've invented medication and procedures. They've even found how the body reacts to bacteria. They are even using it in medication to relax muscles and as cosmetic treatments. But they haven't made a vaccine. They have utilised the toxin found in botulism disease and turned it into a medication. Disease transmission is through consumption of the bacteria or from the bacteria finding its way into the body via a wound. Foodborne transmissions were somewhat understood in the 1820s because of the discovery of the bad sausage. Their research back then concluded that it might be due to hydrogen cyanide or botulism, but people also had belief that witches were to blame for the people's sickness. Wound transmissions were less known in the early times because they were less common. Nowadays, transmissions, whether it's wound, infant or foodborne, are known to be transmitted through spores. The idea of it being conducted by witches and sorcery is long gone. People have accepted the new ideas of the disease transmission because the facts are overwhelmingly undeniable. Science has proven results of the transmission through studies and tests rather than opinions and ideas. As science evolved, so does the society it evolved in. What professional scientists are discovering, students are learning. This means young people's minds are biased towards science research and expert opinion.